Hello everyone, welcome back to the open class. So can I just get a confirmation if you can hear me? Let me just double check quickly on my end. Hello everyone, welcome back to the open class. So can I just get a confirmation if you can hear me? Let me just double check quickly. I think there's a bit of an echo, so I would have to switch to headset. Alright, 1, 2, setting echo. Okay, so let me, yeah, okay, I think it's because of this. Alright, audio is okay, got latency. How bad is it, Sonia? I would need to get an estimate. I try to have things changed today, but let's see. Okay, yeah, muted, thanks. Alright, so I'm gonna switch to my screen so that maybe we can talk about some of the stuff that's going on, I think. Alright, so this, can you see this? And how bad is the latency yet at the moment? So okay, I think alright, 1, 2, loud and clear. Alright, so I wait for a little bit to hear if everything is now okay. I muted the streaming page, so I think we should be okay in terms of echo and replays. But alright, so okay, if this is your first open class, what we're gonna do is we're going to create a project. So we're gonna fork this project that we have developed for you so that you can keep it and have it for as long as you want and use it for learning purposes. And if you do happen to get the board box, you can also use it for developing as a platform for beginning to develop and learn using the board box that we offer. So what I'm going to do is I'm going to fork this project as well so that you can see how it's done, and then we're going to open it, see if the simulation loads correctly, and then we will get going. Alright, if you all managed to fork the project, so just let me know in the chat if you've managed to fork it. Let me just check something quickly. Okay. Alright, so let's see if we can get it to load real quick. So what we're gonna try to do today is we're gonna connect to the real robot so that we can at least see that whatever is happening in the simulation, we can get the same thing to happen on the real robot as well. So but first we'll get to explain the nitty-gritties and then try to help understand what are publishers, why do we need them, and how do we begin to create a publisher for publishing to the command file topic or the topic that the robot listens to for velocity commands. So the topic that the robot will listen to in case you command it to move forward, to move backwards, to rotate, or to do anything that is related to movement. So I think this one is loading pretty slowly for me. So what I'm going to do is I'm going to switch to a preloaded one, and then we can switch back to this one for connection to the real robot. So just hang on for me. Alright, so let's switch. Okay, so this is what you should see if it is loaded, but this is in TC3, but you don't have to worry about it. What I want you to notice is that you will see this simulation here on the left, right? So this is what you will see. So if you click on that simulation, you can rotate it so that you look at it from the top. Then you will see the robots that we will be using today. The robot will be using this fastbot 1, the red one here. So can I get answers if you have managed to load the simulation and rotate it to this view? Can you see it? Is it loaded for you? Let me check the chart quickly. Okay, Sonia says launching simulation. Alright, mine is still loading on the other window, but anyway, we'll talk about some more detail about what we need to do as we wait for this to load, or we can use the one that is already loaded. I want the other screen that I had set for using it to connect to the robot. So right now it won't affect us much. So I'm going to switch to the one that you see, and we'll get going. Alright, so for now, let me just show you how to control the robot. So if you tap on the robot, you can use the arrows to move it backwards and forwards, and use the left and right arrow to make it rotate. So this is slightly different from Hello, but it's something you want to move the robot to the corner, you can use that. And what we want to do after we have finished developing our code and adding the code to the C ++ script, we want our robot to start from here. So I would recommend you have your robot somewhere in this place on the extreme right if you're looking at it from the same view that I'm looking at it. Otherwise it will probably be left. So I'll zoom out again so you can see where it is. So towards this guy here. Because what we want to do is we want our robot to be moving in this direction. So we're just going to be publishing command velocities values on the topic fastbot 1. So let me expand this note a little bit, and I want to check messages real quick. Okay, no messages. All right. Okay, so the topic that we will be publishing our command velocities, right? It's called fastbot 1. So I will show you how you can find that information. So this is the topic that our robot will subscribe to receive commands to move in a particular direction, right? So the way you find out, let's say you have got a robot that you know you're connected to, but you're not so sure what the topic name is, right? You can use the terminal. So hang on for me real quick. I want to see if you are seeing what I'm seeing here. So yes, cool. So we are in the same view, right? And what we're gonna do is to figure out what topics are available in the first place, actually. So you can run this command. So ROS2 topic list, right? So this will tell you all the topics that are currently available, right? And if you do that in this simulation here, while this simulation is running, you should be able to see the command velocity topic for the fastbot 1, which is the red one here that we said we want to move today, this one here. And you should be able to see also command velocity topics for this one here, fastbot 2 and fastbot 3, right? Because they are all in the same simulation, so they should be publishing, or they should be ready to receive command velocity values on their particular topics, right? So if you look at what's happening here, so we've got fastbot 2, so this is for the green one. Let me double check if that's the one with the number 2. Yes, right? And then we've got fastbot 3 command vel, right? So that is the topic that a fastbot 3 will listen to for command velocities, right? And then we have got fastbot 1 C command vel, right? So which is here, right? So this is the topic that our red robot here, the red fastbot, this is the topic that it listens to for command velocity. So whether you are publishing in the terminal, for example, or you create a script or a program, a C++ program that will move your robot in a certain direction or in a certain way, right? For it to do that, it has to publish the command velocities on this topic here, fastboard1 command vel, right? Is any one of you, or have you managed to at least do replicate what I've shown here? So ROS2 topic list, and are you seeing the topics? So if your simulation is running, as long as it's not still loading, you should be able to get these topics, right, for the various robots. So let me check real quick to see if we might have any messages here. Okay, no messages. All right, but I just want to get a yes or a no if you managed to get things going, or just a thumbs up. And how is the latency? If Sonia can let me know. All right, so let's go on in the meantime. So okay, so we are here, right? So what we do from the last open class that we did, we developed a subscriber. So subscriber is a node that listens to a message. So what you should have in mind that obviously in the robot there should be some form of subscriber that listens to one of the devices. So running the definitely the subscriber, but that subscriber is first one because it receives to move the robot from another. So today we want to do is we want to get the publisher, right? That publishes message to this topic that called fastboard command velocity 1. Right. So what this will enable us to do is it will enable us to move forward in way we want. Like this will be very simple thing. So let's run you through the things that we're gonna be doing in this procedure, right? So we're gonna do this exercise. So the first one is, if you remember from the previous class, if you were there, if you're not there, it's fine. We're gonna do the same thing. So first we'll begin by creating a package, right? Because what we want to do is we want to control our robot by using a script. So we don't want to publish command velocities. You can do that. What we want to do is to have script runs so that you can at least create several types of movements, right? Because if you're publishing in the terminal, for example, what happens is your robot moves in only one way. So we create so you know that if this one is publishes a rate of 10 so can publish one of a this one is a width is values, right? This one do or beta blue and also however this is interface, right? So for every topic that you've got in ROS 2, there is a interface associated with that. So for the first one topic, which is here, right? The message associated with this is a comprises of linear comments and FIZ and then right? But more of this down to the two blocks down to the floor of thousands. So I'm going to this one and put it in our terminal so that we can execute this. But we're going to change the robot to something. So let's minimize this a bit and we can see our terminal here. So I'm going to so that we can have clearly what's going on and we can let's clear this quick twice. Right. Okay, so now what we want to do is we want to move forward with a particular velocity in the forward direction. So we're gonna pick value for 0 and 1, right? So in the one that forward, right, you have to use your arrow in the terminal and then in the x-axis, right? That's the one move forward. So forward is x. That's where the robot is, right? So if you in the right so forward is always robot and then that's your x direction, and then left side that is where your y axis is, and then top, so your head or the top of the that's where the z axis goes, right? So in case when robot come forward, it's a move for this if it's so we're gonna change this right to 0.1, right? Then publish. So let's see if this works. So just have a notification and then we wait and start publishing. So you can see what we're doing, right? So what you have to do is once you see your robot to like as always let's say right? So the robot keeps saying this one. So what you have to do is you have to use that list value 0. If you again scroll to the point where it's 0.1, right? And then set 0. I can show you that this is actually is happening, right? So if you click on your robot and you move it backwards, it keeps moving forward, right? It's because the subscriber is latched onto this value. So you have to do is and we are going to reset this to 0, right? So I think the easiest way, if I could get my arrows to respond quickly, give me 1 sec. All right. All right. A bit of an issue, but let's do, okay, one more, and then we can remove this one, and then add 0 here. Then you press enter, and you should be able to see that your robot is not moving anymore. So if I press here again, once we have started publishing the resetting values, okay, hang on, right, sorry for the change of view there, but I wanted to click the robot, so you should be able to click the robot. So we can escape this and then do it again. So here, so now, okay, it's still moving, which means it is not reset the value. So let's try again, or just to check if it's doing what we want here. So Control C, and let's go again. So I'm going to clear this a bit so that we know what's going on, and Control V here. So right, so we've got 0, 0, 0, so we press enter, and then we should be able to get the messages being published on the topic with the zeros. So if I click here again, okay, let's get it to the view that we wanted, right, this one here, and okay, it's a bit sensitive, but yeah, okay, it's still it's not receiving the messages, I think, but no worries. We will try again. Control C. So let me just see if I can get us to have a smoother flow here. So just give me 1 second. Let me check the charts for a little bit. Okay, huge latency. Okay, let's try a different setting. I think we might be able to get away with a change in network. So all right, so 1 2 1 2, can you hear me? Is this a lot better? So let's go back to that project and see if we can get it to respond to the way we want it to respond, right? So can you just send me maybe a message or a thumbs up if latency is a bit better? I think you had to lose me for a little bit there when I was changing, but let's see. So we see that our robot is still publishing, it's still receiving those, or it's still is late as its value is latched on x value of 0.01, right? So let me refresh my terminal a bit. I think it might help. All right, this one, okay, done. All right, how is the latency, Karthik, if you're still there? Okay, so I was trying to get us to stop this robot, right? So let's go again, and I hope it works this time around and it receives those values. So it's still something. This might require us to reset the simulation, but I could do that if I still have this one loaded. Okay, let's just reset the simulation a bit, but as we go I will have to be talking about more details so that we don't lose time. Okay, so if you would allow me, I'm just going to try and reset our simulation. So okay, So as that loads, let me continue talking about what we're going to be doing. So I said our first step is going to be creating the package, right? So without wasting any more time, so as the simulation loads, you can copy these commands here. So what this will do is you to open your SRC directory in the ROS workspace, right? And then we're gonna use the below command to create our package that we're going to use as our publisher for command velocities values, right? That are going to be publishing to fastboard1 fastboard_1 / command file, right? So what I'm gonna do is open our IDE, right? So open the IDE here, and so that we could be able to see, okay, I think something is going on here, so that we could be able to see what's going on, right? So I'm gonna stop this and then clear, and then so we're gonna cd, so open this directory here, ROS2 workspace directory, and then in here you're going to open the SRC directory again, and you should be able to see this fastboard robot description. And then for you shouldn't have this if you have not created the package, but for me I already have it. So what I'm gonna do is I'm gonna remove it, and then we're gonna create it together from scratch so that you get to understand the stuff that we're doing, right? So I'm gonna remove it here and then ls. Okay, so you should be having something like this, right? So you should just have fastboard description and fastboard multi .rvs, right? You don't have to worry about those files. They're just there because they are used as part of to help the simulation in some way, right? So don't worry about them. Let me just check real quick. Okay, we're still going here. All right. So I'm gonna go back to, okay, I think I'm not seeing any messages yet, so let me refresh this just a little. Okay, yeah, we should be okay. All right. So to create, right, so to create a package, you use this command. So it's called ROS2 package create. So we're gonna break it down like we did in the last class, in case you were not there. So I want to clear this so that we have more space, right, to be able to understand what's going on. So to create a package, you call the command ROS2 package create, and then you specify the name of the package you want to create, right? And then the build type. So if you remember from the last one, or if you're not there, I'm going to explain it anyway. So the build type specifies whether you're making a C++ package or a Python package, right? And then the type that we use in C++, if you're using C++, is a main CMake. So I'm going to stretch this a little bit so that you can see it in one line, right? So this is the type for C++ packages, right? If you're using Python, you will have here amend Python, right? And then the dependencies, right? So the dependencies are the libraries that your package will use from the ROS framework or from the ROS2 ecosystem, right? So for us, the packages that are going to be used is a RC or CPP, so that's the ROS client for C++ packages, and then geometry underscore MSGS, so that is the package for twist messages, right? So if you remember what I said earlier, that for every topic that you use in ROS2, there is a particular message interface associated with it, right? So that is the definition of what type of message or what data types are allowed with that topic, right? So for the command velocity, right, the interface is made up of geometry twist messages, right? So the message itself is made in such a way that it has to have a linear component of the velocity, angular component of the velocities, right? So what I'm going to do is, after we create our package, I'm going to show you how you can see the interface, right, and get a very good understanding of what does the message that you're supposed to publish comprise of. So once you have copied your command here, you can press enter, right? and then you should be able to get your package B created, right? So you can see here our package has been created. So what I'm going to do is I'm going to do ls, so to list the contents of the directory, and then we can see that now we have our package here, right? And then in our package, if you open or if you get into that directory, right, so cd again, and then you list the contents of that, you should be able to have a CMakeList file created for you, and you should be able to have and include a directory in there, a package.xml. So the package.xml, I will open it so you can see it in more detail, right? But what this is, it is a dependency manifest. So every time you add dependencies, like we have done it at the beginning here when we created a package, right, these dependencies are added to the package.xml file so that the ROS2 compiler or Colcon will know that, okay, I need to get these libraries when I'm building this package, right? That's so the role of the package XML is to list those dependencies. That's why I said it's a dependency manifest. It holds what is needed for the successful building of that of that package, right? So let's go back here, right? And then we have the SRC directory. So the SRC directory, it's created for you again by default, but every time you use you create a C++ package, right, you will add your source files in that directory, right? If you happen to be creating something that requires headers, so if you want to separate implementation and interface, right, you'd have your interface in the include directory. So those are the headers. If you have had previous experience with C++, and then in the SRC directory, you will have your CPP files or your implementation files, or let's say in the technical term, that's where you'd have your .cpp files in the SRC directory. So what I'm going to do is, for the sake of our understanding, I'm going to open the include directory so that you can see what it has got, and then how you would end up how you would do it if we're going to split interfaces and headers. Interfaces and implementation, right? So if you go list again the contents of that directory, you will find that you have got a folder that is named exactly the same way that your package is named, right? So what you'll do is, if you're creating any headers, you'd have to get into that directory, and then I'm just listing the contents here so that you know that there is nothing in it. But what you'd have to do is you'd create your headers in that in this workspace here there. So okay, enough of that. I wanted you to know about that bit. Anyway, what we're gonna do for us though is we want to open the SRC directory, right? In the SRC directory, this is where we're gonna create our file that will contain our source code for the node, right, for the publisher node that we want to create. And in that SRC directory. Alright, so we're going to use the touch command. So touch command is the command that you use in the Linux shell that we're using in the moment to create a particular file, right? It can be any other file that's not a CPP file, but for us, we want to create a CPP file for our publisher, right? So maybe if you've worked with other, like Ubuntu systems, for example, you can probably use Nano or maybe Vim, but then those will require you to edit the file in there. What we want ourselves is to just create the file, and then we'll edit it in the IDE that we have here. So let me just check real quick where we are in terms of our progress. So we have specified that we need to create a package. We have created that package, right? So what we're gonna do is, we're now on this step, right? We are going to create a script that we call command velocity sender.cpp, right? So that's the script that will hold our source code for the node that we going to use to publish command velocities, right? And then after that, we'll create a launch file, right? And then we'll do some modifications to the CMakeList file to allow the compiler to know, okay, that there is this new source file that you have to compile into an executable, something that you can run. That's an executable, right? And we're going to compile the package, then launch the program. Okay, so since we are still here, right, where it says inside create a file, we're gonna create a file using the touch command here. So let me check the messages real quick. Okay, I think okay. All right, so let's go on and create that file. So touch, right, that's all you need to do, and then you specify the name of the file. Okay, so our file is going to be cmdval, right, and cmdval sender, okay, dot cpp, right. So you press enter, and then you should have your file created. So if you type ls again to list the contents of the directory, you have got cmdval sender created, right? So let me just double check the name so that we won't have problems when we compile. Okay, cmdval sender.cpp, right? So if you go here and you check in your ROS2 workspace, so remember we created it in the SRSC folder. That's where you always create your packages, right? If you may have more than one package, but they all should be in here, right? And these build, install, and log files, they are added when you compile. So we may even, when you load yours, you probably may have this or may not, but I'm thinking you'll probably have them as a result of the simulation, right? Because the build and log and install files, they are created there when you compile. So because there is this fastboard description package that was there when you forked the project, you will have these files there. However, what I want you to understand is, in cases where you have an empty workspace, right? You have an empty workspace. You have just created a workspace that you call ROS2 workspace, or maybe another name and then underscore workspace, right? The SRC directory is something that you have to create yourself, right? So it's standard practice that we put every package in an SRC directory that is within a ROS2 workspace or any particular workspace, right? It's how the ROS and ROS ecosystem has worked for all along, right? So it has become standard procedure, and I highly advise you follow that procedure, right? So your workspace may not be ROS2, but for us at the construct here, it's always ROS2. So that's how you know, okay, this is where my source files are found, and then in the SRC directory, right? So if we open our recently created package, right, you are going to see that there is this file that we've just created here, right? And it's going to be empty. So we will be adding our code to this file so that we can get our robot to do what we want it to do via the publication that the command velocity publisher will be doing, right? Okay, so what I also want you to know is, in case you didn't know, you can also modify files using Vim. So if you didn't want to use the IDE, it's a good thing to know. It's standard practice. Sometimes as you develop in your robotic career, you may find yourself working on systems that don't even have the hardware capability to support an IDE, for example. So you can use Vim in the terminal. In other systems, if you have Nano installed, maybe you can do that. In systems that do not come with Vim, you can install it. But I just want you to know that you can do these things. So you can go Vim, and then you specify the name of the file. So this one, we call it cmdval sender, okay? And you press tab for autocomplete if you want, and then you press enter. So what you see is that Vim will open the file for you, so you should be able to get an empty file. So this is an empty file here, and it's a good thing to know. So to exit, you just press colon. You have to press escape in case you're going into insert mode by pressing I. So if you press escape, then you press colon, small letter Q, then you exit, right? So it's a good thing to know, but not our main topic right now. So now that we have our file created, let's go on to copy our code. So here is the code that we'll be using. So we're gonna go via this code step by step, so that you understand what it's doing, and then we see it running simulation. Then we're gonna connect to the real robot to also see, right? To also see that the robot will respond the same way that the one in the simulation was doing, right? So if you use this icon here, sorry about that. Okay. All right, so once you have copied the code, I highly recommend that because sometimes using this icon for copying, you may get extra spaces inserted, or you may get other characters inserted that you don't want. So you can just use Control A once you click that cell, and then Control C, right? Then in the file or in the command.cpp in the IDE, you can then copy the contents, Control V, and then you save that file, right? So let's open this in full screen mode, and then we can look at it a bit more, right? Let me just check messages in case there are some messages. Okay. Okay, no messages, right? Okay, so let's go through this line by line. So what's going on here? So we are creating our node, right? So this is the demo of our class. So this is the node is defined in a class form, right? So the name of the class is called cmdval sender, right? And then we are inheriting from rcocpp node. So if you remember what we said earlier, that we need the rcocpp dependency, this is the reason, right? Because we want to inherit from the node class, right, in the rcocpp namespace, right? And then after that, inherit all the methods that are required when you're defining a standard node, right? And then we use any one of them that we want. You will see that some of them include this, a create publisher, okay, I think let me close this window for now. All right, so now this, you see that here we are calling this, and then we call the templatized function create publisher, right? So this is not defined anywhere in our class, right? It is not defined anywhere, you can see, right? But the reason why we have got this ability to call it by using the this pointer is because we have actually gotten it from the rcocpp node class that we have inherited, right, as a result of us having included rcocpp client or the ROS C++ client library, right? Okay, so and then what we have here is our constructor, right? So the constructor is the member function. I'm putting it in quotes because it depending on how you look at it, you could call it a member function, or I would rather prefer that we call it a constructor. That's it, right? Let's not call it a member function because it's not really that, but it is the thing that creates our object, right? Our object or our class, right, or our node is going to be created by this constructor, and it's going to be named command val sender, right? Because this is the node that will be publishing a velocity values onto the fastbot 1 topic, right? This one here. And if you remember from our notebook, this is exactly the way that we want it to this is the way that the topic is labeled, right? Now this 10 here, so this says, okay, publish your messages at this rate, right? So you're gonna have 10 messages that are going to be like, let's say, kept for publishing, right? Once they exceed that, you cannot really be publishing an 11th one at a particular time. So this is something related to QoS, right? So what this will do is it will also enable you to specify in your subscriber that, okay, I want you to keep a queue of 10 messages, right? So that anytime an 11th message comes, you discard the oldest one. So this is ensuring let's say working together or agreeability between the publisher and the subscriber, right? So the QoS, their QoS is to match, right? But that's enough of that detail. You would have to specify it though, so that your publisher and the subscriber, they can talk to each other nicely. But there are more things that you can modify as far as QoS is concerned. We won't get into more detail about it. What you should know, however, is that QoS, which means shortcut for quality of service. It is responsible for ensuring that there is effective communication between your nodes without losing messages or by keeping the messages only that are essential, right? So if you remember what I said, your subscriber will be defined in a similar way, and it will probably have 10 as well to say, okay, you as a subscriber can accept 10 messages, but once an 11th comes, you discard the oldest one so that you keep the memory usage in check. Otherwise, you cannot ask your system to be keeping all the messages that are coming. You would eventually run out of memory in any way, right? So anyway, now so this is what happens when you call the constructor, right? You create a publisher, and then it's supposed to publish on this topic and using this many messages, so 10, and then it will be publishing on this topic using this message, right? So if you remember what I said, that with every topic there is a particular message type associated with it, right? So for command velocities, or for this one, the message type associated with it is geometry messages twist, or geometry MSGS twist, right? So now what you would want to do is you want to know, how do I get this, right? How do I know that this is the message type that I'm supposed to be publishing on, right? So I can show you that real quick. So if you go in your terminal and you type in ROS2 topic info, right, and you specify the name of the topic, so you say fastbot _1 cmd file, right, and then you press enter, right? So here it tells you that, okay, the type of message is geometry messages / msg twist, right, and you only have got 0 publishers and 2 subscribers, right? So okay, now when you get that, if you want to get more detail about what does the message look like, right, you can do ROS2 interface show, right? If you remember what I said, that there's a breakdown where you see, okay, this is the linear part, this is the angular part, so you want to get that detail. So if you use ROS2 interface show, right, and then you specify the interface that you want to see, so geometry messages, right, _msgs /msg / twist, and then you press enter. You should be able to see, okay, these are the fields that you've got. You've got a vector3 field that is called linear, and it has 4 float 64 let's say data containers, for example, or it comprises of 4 float 64 types, right? So there's one that is called X, another one that is called Y, another one that is called Z. The same thing applies here. It's a vector that we call angular, and each part of that vector represents a angular velocity in a certain value in a certain axis. So this is float 64x, so this is angular velocity in the X direction, angular velocity in the Y direction, angular velocity in the Z direction. Okay, so because I want us to connect to the real robot real quick, so we're gonna try to create a launch file. We're gonna create our launch file as well. So what you have to do is you're gonna come down here, right, and then you see we'd have to create a launch file that will launch this node, right, so that it starts moving the robot, or it starts publishing the values, right, so that we can see the robot move backwards, forwards as the code specifies, right? So what I want you to see, okay, for now let's just create the launch file. We can get into the code details later. Okay, so a launch file is always created in the launch directory. So what I'll do is, let's go here and list again the contents of our package. You see we have got include package XML src as I've shown earlier, but the launch directory is not there. It's always named launch, right? So we're gonna make that directory, so mkdir launch, and then if you now list, you have got a directory that is called launch here. So this is where we'll put our launch file. So it's standard convention in ROS that you will, if you want to have launch files run your nodes, put them in that directory. If it's not there, create it, and then you can put your launch files there. So this is the name of our launch file, so command velocity sender.launch.py. So we're gonna get into that, right, and then list it to just make sure there's nothing else. You see there's nothing, so we use the touch command here, and we will name it exactly the way it's named there. So velocity sender .launch.py, right? Alright, then you press enter and you should have your launch file created. So ls, again, to list the contents, we have it. So if you go here and you open your launch directory, you should have your launch file here. It's going to be empty, yes, right? So Control A, Control C, and then you paste it in your launch file there. So Control save, we save it, right? Now we're going to, if you remember what I said earlier, that we would need to tell the compiler that it needs to compile our executable and to compile our source code and convert it into an executable, right? That is a node that will run. So it's going to be done, or that specification is done in the CMakeList file. So if you remember what I said, the package XML is a dependency manifest. So it's the package, is the script, or let's say is the file that is responsible for keeping the list of dependencies that your package uses, right? And letting the compiler know that, okay, you need to include this, you need to include that, you need to have that there, or you need to have these things ready, so that when the CMakeList, when the compiler goes through the CMakeList to create or build or compile your package, right, it will know that, okay, I have to look for this and make it available for the compiler during the process of making that ROS2 node executable, right? So now let's modify our CMakeList file again, not again, I mean to make it a way that we want it to compile our executable, right? So let's look at this just real quick so we know what is going on, right? So we have this line here, that is add executable, right? So what it's going to do is it's going to create an executable from our source file, and it's going to name that executable command velocity publisher node, right? And it's going to link the dependencies. So this node that we've got here, right, our node requires RC of CPP, so the ROS client library and the geometry messages as dependencies, right? So the linker will have to link these things together. That's why we have this here, right? And then here we install our node in the library so that it becomes available for in cases where it's called, like with ROS2 run or ROS2 launch, right? And then for using the launch system, so every time you call ROS2 launch, whatever your launch file is, it has to be installed as well. That's why we have this here. If we are going to just use ROS2 run, you won't need this, right? Because you're not using launch files in any way, right? So it's a good thing to know that this is the reason why we're doing this thing. So remember, you have to add these things before this line here. Otherwise, if you add them below, your code won't compile, right? Okay, so let's compile real quick and see what this code does. I could go in more detail later, but right now I want you to see what it's doing and to see it compile, see it work. So what I'm going to do is, let me click on the bot because I want to move it to that point that we agreed on earlier, so that we can see it move and it won't really collide with others. So okay, now it's moving, rotate it. Okay, so go back. Okay, all right, so let's, okay, why is this happening? Okay, give me 1 sec. Just want to correct our view so that we have the same view. Good. Okay, so let's compile our package. So every time you compile your package, you must be in your workspace, right? You must be in your either ROS2 workspace or whatever name slash underscore workspace, right? That's the convention. That's how you must compile your code, right? You cannot call con in any other file, otherwise you may have issues. Or if you're an advanced user, yeah, you can do that, but you will obviously know that there is some overlaying that's going on. So for the basics, always compile in the ROS2 workspace. That's the folder you're supposed to combine on. So we're going to call con build in here, right? And we're going to use packages select because we want to only build the package that we have created, right? The others have been built before because you did call con earlier on at some point, right? So con build packages select, and you say cmdevel a publisher package, right? So let me see if tab will help me here. Okay, not really going for it. Okay, so let's call publisher package. Is that correct? Okay, something is missing. Okay, right. So okay, it's missing spelling error. Okay, right. So our package is compiling and building, and then we have to source it before we run ROS2 launch. Otherwise, if we don't source the ROS2 command or terminal tool will not be able to find that script because you didn't source it. You didn't include the recently built files so that they become available for running, right? So wait for it to build, and then let's just see a bit more stuff here. Okay, so in the notebook you have this GIF that kind of shows what you're supposed to expect when the code is running, but we're gonna do it live so that you see it happening. Okay, so you remember to source, right? So source install. So you're sourcing this the install directory, right? Because that's where your executables are found, right? So source install setup.bash, you press enter, and then now you can do ROS2 launch, and if you say cmdevel and you press tab, you should be able to see that it auto completes because it now can find that package, right? And you say again cmdevel and you press tab, it can also find our launch file because we installed that launch file, so it's available when you press tab, right? So enter, and then now you can see the robot moves forwards, and then eventually it must move backwards and rotates. But anyway, so there are a couple of things that are happening here. So depending on how you modify the script, so if you remember correctly what I said earlier on, that Control C does not make sure the robot stops, because in our executable or in our script here we did not reset the command velocity value. So I want you to see this so that you will know that it's not that your code is an error, it's just because what we did here is we have been setting values for the different cases, right? So for the case 1, on the basis of what we're using here, so this is a phase count. So what it does is every number that's divisible by 50 modulo 4. So modulo 4 is just there to make sure that this thing happens 4 times. So if you have got like a count that gets to 50, once it gets to 50 you get 0 here. 0 modulo 4, it's still 0. And then if you get 1 in the first count, 1 modulo 4 is 1, so that means it's going to do the case 1 here. So the same thing when you get a number like, let's say 3, so 3 modulo 4, you get 3, so it will execute case 2. Remember, we count from 0 every time, right? But what I want you to understand besides all this stuff is that after this finishes, we are not resetting our values to 0. That's why the robot keeps on moving. As I've said, it latches to those values that you have published previously. So what you have to do is you also have to publish 0 values in the terminal. That's why I put this in the command line in the notes, right? So that you know that once your robot is done what you expect, you have to and you have to publish the 0 value so that you don't have the robot keep on moving even though you have pressed Ctrl C to stop execution, right? Okay, so that's that. What I want us to do is maybe let's reduce this to 20. This might help us, because it won't go as far. Okay, so since we've made a modification, we have to recompile, right? So we're gonna go con build packages select, and let's just reset where the robot was so that we can at least see the whole thing happening without as much collision. So let's go open our, right? So let's So again, as I said, you click on the robot, then you should be able to move it backwards and forwards. Okay, if I can get it to do that quickly. Okay, right. So now you see it doesn't keep wanting to go forward or backwards or anything. It's controllable because we did publish values that we reset our linear and angular velocities, right? So it's very important. It's very, very important for us to understand this, because the same phenomena happens with real robots if that guard is not put in place, where once it does not receive messages for some time, it stops moving, right? It's a very important thing to know. Okay, so let's get back our robot to this first place again and try again with a smaller value so that it doesn't run into obstacles. So we have built. Now we are going to a source again, and then we will launch one more time. So alright, so now you see it moves back and stops, rotates, then moves backwards. Oh, it did collide again, but it must move backwards. Okay, it moves forward. Alright, but I think you see how primitive our code base is, right? Because it does not see obstacles, it cannot avoid them, it cannot even stop in case there is something. So this creates a platform for us to learn about more things, right? And you can see the last thing that was running, or the last values that were published before we pressed Ctrl C, were angular velocity values. And you see the robot is still rotating. This is the latching that I was speaking about. So let me again publish resetting values, and then we can get it to stop, right? So you see it is stopped now. So what we want to do right now is we want to do this on the real robot, right? So if you will allow me real quick, I don't know if you'll be able to see what I'm doing, but give me 1 sec. I will check for you right now. Okay, yeah, you can at least see what I'm doing. So give me 1 second and we'll be able to see what we want to do next. So alright, so I'm just gonna log in real quick and then connect to the real robot, and then we can run it. So let's run our project one more time here, and okay, so let's wait for it to load, then we can connect. Alright, so we're gonna connect to the first bot. Okay, give me 1 second. We want this red one here. Where is it? We want this red one here. So we've been controlling the red one in simulation. What we want to do right now is we want to control the red rear one, right? So this is the beauty of ROS 2 and the first bot box, right? So you can be able to replicate these things on a real robot. So just hang on 1 sec and we will be having it available real soon. So let me check something real quick here. Okay, so I just want to get our robot to start running so we can connect to it. You saw that message is because the robot is not available yet, but it will be available soon. Alright, so as we wait for that, I will explain the code in more detail. So once the robot becomes available, we'll connect to it and then see it happening. So just give me 1 more sec. Okay. Alright, so let me open our IDE so we can talk about the code in a bit more detail as we wait for a robot to become online. And so I think I will have to switch to this one here because this is where we were. So let me just maximize this real quick. Alright, so if you remember what I said, so we have these I want to call them member variables because they are, right? So they are like names that have memory allocations are allocated for them, right? So we've got here that we call the publisher, right? So these things, they are defined here in the class, right? So you can see all of them, they are types that are defined in the ROS client library. So you see here, every time you want to create a timer object or to declare a timer member variable, right, you have to find it in the RC or CPP client library, and then timer base, and then this is a shared pointer, right? So what you're doing is you're initializing a pointer to that object, to that thing, because it's there somewhere, but you want to get it from where it is and then assign it some value. That's why you see in the constructor, we are saying to timer, we are assigning it a value, we are assigning it this here. So what I'm going to do is to break it down, what is going on here, right? So here you see that it says this create world timer, so this is a pointer for this class. So it's like something that is refers to the self. If you have used Python before, that this keyword is similar in some way to the self keyword. If you think about it in terms of what does it mean, right, it just means this thing that is within myself. So it's a pointer to the function that is within itself, within the CMDevel sender, right? So it then assigns the or creates, right? So it says create world timer and then tells it what the frequency or what's the time interval that timer will run it, right? So in this case we are saying, okay, we want this timer to run at like 100th of a second. So it has to run like 100 times a second, right? So that's 10 hertz if I remember correctly. Oh yeah, 10 hertz. So it has to run 10 times per second, right? So, and then what we're doing is this timer, as it runs at that frequency, it has to be calling what is called a timer callback. So a timer, or a callback in general in ROS2 is a, let's say, it is a function that does something on the basis of, or at a particular interval, right? Or when something happens, or when a message arrives, right, the callback runs, right? But this callback that we are creating here, it runs not on the basis of a particular event happening, but it runs on the basis of the timer interval getting to a particular value. So if we have gone 100 seconds, that time is supposed to execute no matter what, right? It's unlike something that has to wait for a particular event to happen and then execute. This one will say, once I've gone beyond 100 seconds, I'm going to execute something, right? So let's look at what this function that we call timer callback does, right? If you look at it here, this is the function that is actually publishing our command velocity values, right? So it's saying every 100 milliseconds publish command velocities, right? So depending on which case it is, right? So if our count of running through this cycle, so remember that this is publishing at 10 times a second, so right? So but every time this function runs, the count will count 1, right? So if it is run for, in this case, if it is run for, let's say 4 times, 10 times 2, so because we are dividing by 20, right? So if we are saying it's publishing at 10 times a second, right? To get to a number that's divisible by 20, we have to run this loop 20 times, right? So running it 20 times means 2 seconds, right? So what that means is that every time we get to a number that's divisible by 20, the loop will start again from 0. So it will start from case 1, right? So what I want you to understand, besides this whole mathematical thing that's going on, is that the timer is just an object that is there to constantly publish velocity values. The reason why it has to happen so frequently is that, so in cases where you are using a system that uses like a sensor like LiDAR to avoid obstacles, right? If your callback here, your timer callback, is running at a slower pace, your robot does not have time to get itself away from that obstacle, right? Because if you think about it, if the publisher or this timer was running at one instance or one cycle every 1 minute, when your robot sees an obstacle in front of it and it's going at 1 meter per second, or let's just say 0.1 meter per second, it might have collided already. So you want it to run as frequently as possible so that you can be able to have your robot avoid obstacles in time, right? So this is the importance of choosing the correct interval for your timer. If it's something that is not very pressing in terms of how quickly it's being processed, you can have a longer interval, right? You can even have like a 500 milliseconds interval, because maybe you just want that thing to run once, right? So that is a bit of detail on that end. So let's just check if we can connect to the real bot now. Let's try again here. Connect. Okay, we should be able to connect. Alright. Oh, there is still an issue. Okay, give me 1 sec. Alright. Alright. Let's try again to refresh our page so we can connect to the bot, and then we'll see. Alright, so I'm not able to see messages right now, but I will try and look at the messages real quick as we wait for this to load. So okay, so give me 1 more sec. Alright, so let's try connecting one more time, and then we can demonstrate what's going on. Alright, real good. Okay, very nice. We managed to connect, so we'll see that we have got something very similar to what we have in simulation, right? So let me just move this to a place where it is similar to the window that we had in the when we're running the simulation, right? So we're gonna have this here, and then we want to have our terminal somewhere here once it finishes loading. So okay, so alright, now we can see we have got a red first bot. I will show you which one once I've seen the one that moves. Okay, so give me 1 sec, and let's allow the terminal to load. It's taking a bit of time, but no worries. What we can do at the moment. Okay, good, it's loaded. Alright, so okay, you see the one that my boss is pointing to. Yeah, that one. That's the first bot that we're gonna be using. So I'm gonna move it using teleop so that you can see that it does move without you running the script, because maybe you need to know, right? So okay, what we're gonna do is we're gonna run teleop. So this is normally available, the teleop twist library or shell tool, right, that you can use to control robots. So once you define their topics to be able to be run by this, you should be able to use teleop wherever you want. But it might take a bit of development time, but I'm telling you that you can use it with any other robot as long as you define what the command move forward 0.1 meter of a second mean, right? Okay, so teleop twist keyboard, and you press tab, then it auto completes for you. But what you're going to do is we're going to do a topic remap, because teleop will only publish to command file, right, without the namespace or without the fastport one. So what I'm going to do is to show you how to do that remap, right? So you are doing it in the command line in this case, or we are doing it in the command line in this case, right? So do topic remap, then parameter, you tell it, okay, I want you to remap command file to fastport 1. So let's put the forward slash here again. So for the sake of making it easier, I've gone to full screen. So fastport _1 forward slash cmdval, right? So the reason why we've done this is because teleop will publish to this, but we want this to be publishing to this, right? Because that's the topic of our robot. So we press enter, and then yep. Now okay, there is a message about deprecation, but we should be using ROS, but it still works. It's a good thing to take heed, though. It will help us in the future, right? So let's minimize this and try to use the arrow. So what you have to do, if you had been connected, what I'm going to do is I'm pressing Z right now to reduce the velocity, because it starts with default values of 0.5 forward, right, velocity. Whichever axis is forward, it starts with a 0.5 meters per second. So that is really high. Our robot will run and crash into the wall. So we have to reduce that by pressing Z. If you want to increase, you can press Q, right? But for us, we want to decrease, right? So now our speed is very low. Let's keep it to maybe 2.4 or 2.5, and then you press I. You see that the robot moves, right? And then you press L to rotate to the left. You have to keep pressing if it doesn't respond. Okay, there we go. And then you can press K to stop. In case it gets to the point and it keeps rotating, that's how you can control where it goes, right? So you go forward again, right? And you go backwards, and then you press K to stop. So what we want to do, the same code that we used, right, the same code that we ran on simulation, we're going to use the same code here. So we want to see, what does the robot do? Does it do the same thing as it did in simulation? Yeah, I'm quite sure it will, but for you it will be very interesting, I think. So let's see how it works. So I'm just gonna name this terminal like cmdval to know that we are it's happening in this terminal, and I'm gonna name this terminal I'm gonna name it teleop, so that we don't get confused of who is running where and why, right? Okay, so this is where we are running our executable. So as I've said, you have to it's advised that you rebuild once you've connected to the robot, but it won't. Well, let's just do it anyway. Let's do it anyway, right? So we're gonna get into our workspace, right? cd ROS2, oh hang on, cd ROS2 workspace, enter, right? And then let's call con build package select, right? And then cmdval, that's the one we want to build. If you do allow me to, okay, it won't. Publisher package, right? Oh, hang on, cd src, let's see it. Okay, it's there. Oh, okay, I see what I did. Okay, let's just call con build, and we build everything. It'll be easier. Oh, I could have copied from the notebook, but no worries. Okay, it has finished building because it had built before. So let's source and then install setup.bash, right? So that we have our executables accessible, right? Setup.bash, right? Okay, one sec. All right, there we go. So what we're gonna do is we're gonna call ROS2 launch, and our package is called cmd val publisher, right? If you press tab, it must be able to autocomplete tab, and then our launch file is called cmd val sender, right? You press enter, and then you can see our robot is moving forward, stops, then move backwards, and then it will stop, then rotate. So the flow is slippery at the moment for the type of wheels that the robot is running, but you can see it's making an attempt to rotate, right? But yes, these are some of the nuances of the real robot environment and the simulation, but you can see it's doing its best to replicate what we've seen in simulation. So what we have to do is Control C, right? For this one, you see that pressing Control C will work. It will stop the robot, but that is because there is an already implemented procedure to publish 00 values everywhere to ensure that it does not keep moving like we have seen happening with the simulation. That's why I was saying it's very important for us to know that once you publish certain values, your node will latch to those values until you reset them, or unless you have implemented a particular mechanism to make sure that once you press Ctrl C in the terminal, the values are reset to 0 in cases of motion, right? Otherwise, for other topics, the case is still the same. There is latching, but then you may not be affected immediately by it. But it's a good thing to know. All right, so that is what I wanted to show you. All right, so what I'm gonna do is let me try to see if I can see some messages in the chat, so that we can talk a bit more. So let me just go home here and try access the live chat. Okay, I don't see it here, so let me Control V. Does it work? Yes, let's see. All right, so messages in the chat. Okay, all right, all good. All right, I see there are no messages, but the good thing is that we managed to connect. Okay, all right, all good. So this is what I wanted us to learn in this project. This is what we were bringing to you as the construct, that you can be able to do these things with the BoardBox warehouse, right? So let me just show you some of the things it comes with. So if you'd allow me here to open this previous project, and I will minimize this real quick. All right, so let's see. So basically, when you get the BoardBox, right, when you get the BoardBox package, you're going to get 3 robots, right? You're gonna get your own red fastboard one, right, and you're gonna get the blue and the green. But this is a very good platform for you to be able to learn or teach others what robotics is like, both in simulation and in the real environment, right? So, and the good thing is that you also get 4 projects that come with this. So you will get the simulation that I've been running with 3 others to different use cases of how you can use the BoardBox simulation to practice in different environments in simulation. You may not be able to have something that is in simulation, but you can try and replicate that environment that you're seeing in the simulation with the current setting or with the current setup that works. So you also get this arm as well, and this conveyor and the part as well, the whole thing, right? So it's very, very handy for link classes, and I think you've seen that every time we've been using the fastboard, right? So if I can go back to seeing when we were connected, so let me show you here. Oh, okay, I think I have to run the receipt, but okay, the thing that I wanted to show you is you can see that there is this protrusion, this green stuff here. So if I can show you in the simulation as well, that's a gripper, right? So I want you to also notice that this green thing here, that's a gripper, and your BoardBox, all 3 of them will come with this. So all fastboards that are used in the BoardBox simulation in the BoardBox warehouse package, they come with the gripper as well, so you can have them practice the things that you are seeing in our GIFs here. So let me go there real quick. Okay, here, so you can see that this one is grasped the block, and then the blue one is also done that, right? And you can have the conveyor running and the arm moving up, things to the conveyor so that the fastboards can take that. So it's a very good learning platform, I think, and because it's not that far divulged or away from how the simulation is designed, it's very easier to transfer your learning. You have seen that the same code that we ran in simulation, right, we didn't make any changes, right? We just connected, and so once you get the setup running, you can just do that, connect to the board or connect to the simulation and run the same code and it works. So it's a very good platform. And anyways, since we are talking about ROS2 and C++, this course will give you more of the details about this stuff, and you can look into a lot more stuff, right? You can look at publishers, the one that we spoke about in the previous class. You can also look at subscribers and a lot more things to do with ROS 2 and C++, right? And if you are new to C++, we also have a course for teaching you C++ for robotics. So that's why you see that we had it here as the first one. So this one will help you. It's a free course. So if you're feeling like you need to polish up on a C++, you can do that. So all right, and that's what we wanted to show you. That's why it's the board box and how you can use publishers to command your robot to move instantly, right? So, and yeah, I wish you all the best, and until next time, keep seeing your ROS learning. Bye bye.